Good afternoon to all the participants, and thank you very much for attending this webinar. I am Fabrizio Celli, a software engineer from the Food and Agriculture Organization of the United Nations, and today I will show you a system which can support the collection of information from the web, especially in the agricultural domain, but not only. We can call this system as the crawling system. So I will start with a short description of the purpose of this webinar and what we would expect from you, from the participants. Then I will describe the two main software components of the system itself. Lastly, I will talk a little bit about the AGRIS use case and how the crawling system can enrich AGRIS, allowing its user to efficiently find relevant data that they need to analyze and to process for many purposes, as for instance taking better decisions or to simply deepen the knowledge about a specific topic. Karna already gave you some background, so the crawling system is a SemaGrow demonstrator, and SemaGrow is a project founded by the 7th Framework Program of the European Commission. SemaGrow's goal is to define and to develop algorithms, but also methodologies and infrastructures to cope with the large data volumes and also real-time performances. In this context, FAO developed the crawling system, which is mainly based on two command line applications, a WebCrawler and the AgroTagger. I will give you more details about them very soon, but now it is important to understand that there are no user graphical interfaces for the moment. We are talking about back-end command line applications. At the end, the final goal is to develop a graphical widget in the AGRIS web portal containing some resources discovered on the web and interlinked to the AGRIS database. In the next slides, I will talk also about AGRIS for the participants who don't know it. After the webinar, we would like to receive some feedback from you. I know that you are so kind that you will have many comments and suggestions. I would like to tell you that you can send the feedback also by email at this address, agris@fao.org. But also we would like to have suggestions on other real case scenarios for the crawling system, especially if you will find the system interesting, and I hope so. In fact, here I am discussing about its application in the AGRIS context and in the agricultural domain, but probably it can be useful also for other needs. Moreover, the two components of the crawling system are available online, so you can download them and play with them, and maybe you could give us some comments about the documentation and about the workflow that they are going to implement. Now I will start to describe the two main components. I will start with the WebCrawler. The WebCrawler is based on a tool called Apache Nutch, which is an highly extensible and scalable open source web crawler, and it is also highly configurable. So we created a customized version of Apache Nutch, and if you consider the system as a black box, we can say that the input of the system is a list of preselected URLs, because this system is going to crawl the web, but we have to give to the crawler a starting point to start the process. The output is a list of discovered URL. How does it work? So the user defines a list of websites, and since they are the starting point for the process, we can call each URL a route for the process. Then the user defines also another parameter called the depth This is the number of hops to discover. This is the number of hops that a discover link is away from the root, with the idea that links very far away from the root maybe don't hold much information. At this point, it is possible to start to crawl the web. In this picture, you can see an example about the parameter depth. So, the root is one of the URLs given as input of the system, of the process. The web crawler can parse the content of this URL, and it can discover many other URLs. And we are at the first level. For each of the discovered URL, the crawler applies the same algorithm. I mean, it reads the content and discovers other URLs. So we are at the second level. When the crawler reaches the third level, it stops, since in this example the depth was 3. Our customized version of the crawler, the web crawler, is available at this address in GitHub. This is a command line application provided with some bash scripts to run in a Linux environment. Of course, the application can be used also in other environments, also on Windows, but you need to write a batch script. In fact, in this application, the application that you will download, you will find directly the bash script for Linux. I want to show you also an example of usage of one of these scripts. For instance, the Crawler exec script. This is an application to run the crawler, so it needs as first parameter the depth. In this example is 5. Then it needs the output directory, the path to the output directory, where the crawler will add the discovered URLs, and then also the path to the input directory. The input directory contains some files, and each file should contain a list of URLs that will be the root for the crawler. This is an example of output of the crawler. As you can understand, it is a text file containing many URLs, even if with some special keywords like URL, outlink, and anchor. But this file can be easily parsed by the next component, the AgroTagger, so the output of the web crawler can be also the input of the AgroTagger. And now we will see a little bit the AgroTagger. First of all, I have to introduce AGROVOC, because the AgroTagger is based on this thesaurus. AGROVOC is the FAO multilingual vocabulary containing more than 32,000 concepts in up to 21 languages. It is part of the LOD cloud, and it follows the SCOS data model, the Simple Knowledge Organization System data model. AGROVOC is extensively used by catalogers for indexing data in agricultural information system, and it is available also in a public Sparkle endpoint. So at this address you will find the AGROVOC Sparkle endpoint, and you can use it for your own purposes, also to enrich your own applications. The AgroTagger is a sort of keyword extractor that currently is using the AGROVOC thesaurus to extract keywords from some input URLs. Or better, I told you that AGROVOC is published as linked open data, so the AgroTagger does not extract only keywords, but URIs of AGROVOC concepts. The engine of the AgroTagger is based on Maui. Just to give you some background about the name Maui, Maui was the name of a Polynesian demigod, and the legend says that this demigod was able to transform himself into different kinds of birds to perform his exploitations. So since Maui uses different kinds of algorithms and mainly Kea and Weka, that are the names of some New Zealand native birds. This is why they choose this name for the tool. As far as the two algorithms concerns, Kea is a key phrase extraction algorithm, and it can be either used for free indexing or for indexing with a control vocabulary. While Weka, or better Weku in the original language, is a machine learning toolkit developed in New Zealand, and it can be used for data analysis and predictive modeling. Now, Maui can automatically identify main topics in text documents or in other kind of documents containing text. How does it work? Always considering the tool as a black box, then if you want in GitHub you will have further instruction about its implementation. We can say that the input of the tool is a text file with a list of URLs, because the AgroTagger has to start from one or more URLs to extract keywords from text. Or the input file can even be the output of an Apache Nutch WebCrawler. As we saw, it is a list of URLs with some special keywords, but the AgroTagger is able to parse it. The output is simply a set of triples. So using the predicate this terms subject, the AgroTagger is able to assign some AGROVOC URIs to an input URL. Now, just to talk a little bit about the algorithm, I told you that the input is a set of URLs. For each URL in the input file, the AgroTagger first of all downloads the resource. Then it runs the Maui indexer, which was trained with AGROVOC, but you can train Maui with other thesauri. This is why now we are applying this tool to the agricultural domain, but you can have another thesaurus expressed in the SCOS data model, and you can train your system with your thesaurus. And at the end, Maui the AgroTagger creates a set of triples. The process is completely multi-threaded, especially in the download part, so it can download many files together. But currently, Maui is trained only for English. There are some problems, because it is true that it can be trained in other languages that use Latin characters. But we need other solutions, for instance, for Chinese, Arabic, and Russian. Also, this application is available on GitHub. This is a command line application entirely based on Java. Again, on GitHub you can even find some bash scripts to run directly the application in a Linux environment, but this is Java, so you can also run the command Java from the command line. And as before, I want to give you an example of usage of one of the bash scripts inside the application. In this situation, there is the tagger-dir script. This is one of the starting point to run the AgroTagger, and it requires 4 input parameters. The first parameter is the path to the directory with the source files, where each file contains a list of URLs, or it can be the output of a web crawler. The second parameter is the path to the output directory, where the AgroTagger will store triples. The third parameter is the type of the source files in this situation is Nutch output. It means that the source files are the output of the Nutch web crawler. But here you could also have list URLs to say that the AgroTagger will find simple text files with list of URLs. And then there is the output format. In this situation, we are specifying RDF and triples as RDF serialization for the output format. So, this picture explains again the behavior of the AgroTagger. We start from a list of URLs. The engine computes and assigns AGROVOC URIs to source URLs, and as output we have some triples using the DC terms subject predicate. Now, once I have described the two main components of the crawling system, I can talk a little bit about their application in the AGRIS context. Our goal is split in two steps. We are at the end of step 1. So for the moment we are only talking about the backend, the command line applications. In the next year we will develop other algorithms to improve the AGRIS web portal using those applications that I am telling to you. But first of all, I have to introduce AGRIS for participants who don't know it. AGRIS is a web portal. And it is also a database, a collection of more than 7.8 million bibliographic references in agriculture, where the topic agriculture here is considered with as a broad term. I mean, it contains also fisheries, aquacultures, forestries, and other related topics. Now, in the AGRIS database, AGRIS records come with AGROVOC descriptors. And this is very important, as we will see in the next slide. Since December 2013, AGRIS is also an RDF-aware system. This means that the AGRIS database is now publicly exposed as RDF. So there is a Sparkle endpoint that you can use to query the database and to download the AGRIS records. And then, using AGROVOC as the backbone of the system, we are able to interlink the AGRIS database to external sources of information. So, extracting statistics, distribution maps, country profiles, germplasm data, that are not in the AGRIS core database. So this is an example about how an AGRIS mashup page works. On the left, you can see a normal AGRIS record coming from the AGRIS database. So this is a bibliographic database, and this is an article from a journal. You have a title, you have two authors, there is an abstract, then you have the journal and the data provider of the record, and some AGROVOC keywords. As you can see, in the AGRIS database, in this situation, there is not the link to the full text. Sometimes we directly have the link to the full text. In this situation, the link is not in the database itself. So we try to use Google APIs to discover the full text, and in this situation Google was able to find the full text of the publication. Then, using AGROVOC keywords, or better, AGROVOC URIs, because here in the slide you see keywords, but under each keyword there is one URI. So using AGROVOC URIs, we are able to query external Sparkle endpoints and web services, and to automatically and dynamically extract information from external data sources. So we don't need to centralize everything in our database, but we rely on data owners and data providers who set up their own environments and their own tools, and we can query these tools to get information in the AGRIS system. The usage of AGROVOC as a backbone is needed to guarantee that the extracted information is related to the AGRIS record, is semantically related to the AGRIS record that the user is looking at. As you can see in the picture here, we are extracting some maps from the World Bank, from GBIF, the Global Biodiversity Information Facility. We have also data from collecting missions supported by Biodiversity International. We have other bibliographic information from nature.com. And now we have also a partnership with the Chinese Academy of Agricultural Science, and we can get also information from them. Now, after this overview of the AGRIS system, I can tell you about our project to apply the crawling system to AGRIS. So the core idea is to harvest the web, starting from pre-selected sources of information about agriculture, since AGRIS is a database about agriculture. So what we want to do is to crawl the web and to assign some AGROVOC URIs to resources discovered by the WebCrawler. I am saying that we are using the WebCrawler and the AgroTagger to create some triples. Those triples will be stored in a triple store that we can call the Crawler database. And this is step one. At the moment we are at this point. We are populating a crawler database, discovering information on the web. Then it starts a new phase with the definition of combinations between the crawler database and the AGRIS database. In this way, we will be able to add a new widget in the AGRIS mashup page. As you can see, while we will compute combinations between the crawler database and the AGRIS core database, in the mashup page we will show another box with related resources available on the web. And the fact that those resources are related to the record is given by the usage of AGROVOC URIs. So the current status is this one. At the moment we have a web crawler that can gather information from the web. Then the AgroTagger can compute triples to assign AGROVOC URIs to URLs discovered by the web crawler. And we have a crawler triple store ready for computations. And here is a snapshot of the crawler triple store, so where the subject of each triple is a URL discovered by the web crawler, the predicate is DC term subject, and the object is an AGROVOC URI. What's next? We need the processing phase. So we need to discover meaningful combinations between the AGRIS core database and the crawler database. And here is the first problem. What does meaningful combinations mean? Meaningful, what does it mean? Once we can compute these combinations, we will set up a triple store of combinations, and AGRIS will use this new triple store to generate the widget in the mashup page. After that, we will need an evaluation of the quality of the widget, and this will require the human intervention. So only a person can evaluate the content of the new widget and how it is related to each AGRIS record. Just to tell you about a naive algorithm to discover meaningful combinations. This is only for testing purposes. So for instance, we can define this rule. A combination is meaningful only if there are at least n common AGROVOC URIs between a record in the AGRIS core database and an entry in the Crawler database. So this is a very naive algorithm. And we run some tests on it. For instance, starting from AGCon search, this website, using the WebCrawler with a depth equals to 5, we were able to discover 101,000 distinct web resources. Then we ran also the AgroTagger on these resources, and we were able to generate around 1 million triples. This is our Crawler database. In the table, you can see some results considering our combination algorithm. So, for instance, in the first line, starting from 1 million of AGRIS records and using 3 as the minimum number of common AGROVOC URIs between an AGRIS record and an entry in the Crawler database, we were able to compute 17 million of associations. If we increase the number of common needed AGROVOC URIs to compute the combination, so for instance, when we go to 5, we have 0.6 million of discovered associations. So this is an interesting test, but it can be improved as the rule to discover meaningful information can be improved. Meaningful combination, the rule can be improved. Now, one of the main questions is if the demonstrator can support the user to overcome data problems. I show you the AGRIS use case, but maybe there could be other data problems that can be solved by the demonstrator, or maybe the demonstrator is completely useless. This is why we would like to have your feedback about it and your consideration. As I told you, you can even test the application to give us any comments. And this is enough for this presentation. If you have any questions, also now I am here and I'm available to answer to you.